Hello, we just finished talking about the normal model, what that is, what that does, and how to calculate areas and observations within whole number standard deviations away from the mean. All right, but we know real world data isn't going to fall on a whole number standard deviation away from the mean very often, okay? So what we want to do is talk about, okay, well then how do we handle the situation and how do we compute whenever we don't have a whole number standard deviations, and how do we find out those types of information. So here we go. So Ileana is a new student and she is transferring to Aledo High School when the new quarter begins. Her school's grading scale is not the 100-point scale like our school. Instead, Lanier High School uses a 6-point scale system. Okay, very different, very different. All right, so here are the facts that we know about Ileana's AP Statistics course grade that she got at Lanier High School, and then the facts about what we know the quarterly grade to be at AP Statistics Aledo High School, so that we can give her a comparable position related to students and related to grades of what we say that we have learned. Okay, so here are the facts. Lanier High School AP Statistics class, we have a 6-point grading scale. The mean for the AP Statistics teachers students is 5.1 with a standard deviation of 0.45. Aledo High School AP Statistics students, we have a grading of 100-point scale. Our average, did some calculating yesterday, 86 is our average, okay, with a standard deviation of 6 points. All right. So I want you to think about if Ileana's first quarter grade in AP statistics, so the score that she got, if that she got 5.64, then how would we transfer that to a grade at Aledo High School? Okay? Take a moment, what you know how to do, and try that. All right, so what we find is you probably set up some kind of proportion. Okay, that's what you've been taught forever and ever. Okay, you've been dealing with proportionate relationships for a very long time. So, probably what you set up is something like this. Let me pull this down here. Um, you know, 5.1 is the mean, and then she got a 5.68. At our school, 86 is the mean. So, what does she get at our school? And that would give her a grade of 95. Okay, well, so I say that this is a mistake in thought process for grades because this is making an assumption that the grades are distributed proportionally. And that means every grade has the same probability. It's a uniform rectangular distribution. That would mean there is the same proportion of students who make F's, C's, B's, and A's, and that we would have a rectangular proportional relationship. Do you think that that's the real way that grades are distributed in my class? And that answer is, of course not. It is more likely that grades are distributed like this, where most people are centered around the average. And as you get farther above the mean, you have less and less scores up here in the high values and less scores down here in the low values. So that's a normal distribution. So I want you to fill this in here, okay? So let's fill that in. We are listing first our standard deviations at 0, 1, 2, 3 above, and -1, -2, -3, okay? Then I'm going to put in the values for the 6-point scale at Lanier High School. That average was 5.1 and a standard deviation of 0.45. So I added 0.45 to get that value at one standard deviation up, and so on. And I added another 0.45, and I added another 0.45, and then I subtracted on the left. At Aledo High School, the average is 86 with a standard deviation of 6. So I added 6 to get 92. So if you have a grade of 92, you're 1 standard deviation above the mean. If you have a grade of 98, you are 2 standard deviations of the mean. If you have a grade higher than that, and we had one student who had a grade higher than that for the quarter, then you are an upper outlier. Okay? All right. So now, what is the approximate standard? Okay, so here is where Ileana's grade is located, 5.64. So it's a little more than 1 standard deviation above the mean. So the question is, what does that equate to at Aledo High School? And I can tell you it's not 95. If you're one of the GPA grabbers, you don't want to give her a 95 because she actually will come out less than that. So you want her to have the 90 whatever, which isn't the 95. So we want to determine her exact location. And so we want to know how many standard deviations above the mean is Ileana. How many standard deviations? A little more than 1. Not as much as 2. Probably not even 1.5. How can we figure out her relative position in terms of standard deviations? Well, the way we could do that is this thing called a z-score. A z-score is the number of standard deviations away from the mean. So if you have a z-score of 1, you are exactly 1 standard deviation above the mean. If you have a z-score of 2, then you are a piece of data. You got a grade that was a 98 because that was exactly 2 standard deviations above the mean. So what do you think a z-score of a 0 means? Well, a z-score of a 0 means that you have the average score. Okay, so a 0 is right here at the mean. Okay, what does it mean to have a positive z-score? What does it mean to have a positive z-score? And I hope you know that means that you got a score greater than average. You got a score greater than average. Well, then likewise, what would that mean to have a negative z-score? And you got a score lower than average. Okay? All right, so always keep that in mind. The sign matters. The sign is telling you us where you are in relationship to the mean. Okay, so moving on. So now, oh, and I forgot to pull that song up and have that ready to go. So now we're going to do relative position. So here's how we can get Ileana's z-score. We can find her position, see how far away it is from the mean. Okay, so how far away is it from the mean? And then we want it in terms of standard deviations, so we divide by that standard deviations, and that will tell us how many standard deviations she is above or below the mean. So I have a song here, Go Big Red, and to Go Big Red, and it's something that, oh my gosh, it's going to absolutely, you will hear it every single time that you write down the z-score formula. I still do. So I'm going to play it for you. Here we go.
X minus the mean over the standard deviation. X minus the mean over the standard deviation. Inverse norm of the area below. Inverse norm of the area below. Inverse norm of the area below is the z at that spot. X minus the mean over the standard deviation. X minus the mean over the standard deviation. Inverse norm of the area below.
Now this inverse norm we'll get to later.
Inverse norm of the area below is the z at that spot.
So we're not going to be getting to that inverse norm of the area below today. Okay, that'll be at a later point. Okay, so let's do that. So z-score is the number of standard deviations. The data is above or below the mean. So let's write that out for Ileana. We're going to have her score is computed like this. And actually, let me go ahead and take this down here so I don't give the complete answer away. So X is her data. X is the context value that needs to be standardized. So her context value was 5.64. And so X minus the mean of 5.1 over the standard deviation of 0.45. And so X minus the mean over the standard deviation, X minus the mean over the standard deviation. So that's 1.2. So she, in relationship to her peers, is scoring 1.2 standard deviations above the mean. So we want her to score that 1.2 standard deviations above the mean at Aledo High School. So how do we do that? Well, I see that at Aledo High School, our mean is 86. Okay? So 86 is our mean, plus 1.2 of our standard deviations. And our standard deviations are 6 points. That is how we get her same relative position to her peers at Aledo High School. And that's a 93, not a 95. Okay? So, again, relative to her peers, the mean plus 1.2 standard deviations gives us 93. So, I want you to try these ones real quick. And so we can do some comparison. Okay, so here we go. Suppose a student has 2 quizzes in the statistics course. On the first quiz, the mean score was 32. On the and a standard deviation of 8. Okay, so I've got that information. On the second quiz, the student received a 28 and the mean was 23, okay, and the standard deviation was 3. On which quiz did the student perform better relative to his or her peers? So let me talk to you about how this looks. Okay, so here we go. So here's the data for our first quiz over here on the left. The mean is 32, standard deviation 8, and the actual score, so the X value, the context, is 44. So X minus the mean over the standard deviation is how we get 1.5 for that Z-score. Okay, let's do the same thing for the second quiz. So for the second quiz, here's what we got. The second quiz, the mean is 23 with a standard deviation of 3, and that student, the context, the X, is 28. So X minus the mean over the standard deviation is 1.67. Okay, so what does that mean as far as what's happening? Where is this student located? Which quiz did the student score better on relative to his or her peers? Well, I hope you can see that that student scored better on the second quiz because the student's actual score is more standard deviations above the mean than the first quiz. So relative to the peers, you are higher up on the normal model. All right, very good. Let's do the same thing over here with this husband and wife team. So take a few moments, read that, and then compute it. So I'll give you a few moments, pause, so you can practice that, and then we'll give those answers. All right, so you have worked those out yourself. So here we go. The husband's information is such. The mean standard deviation, and he actually makes 1460 per hour. So X minus the mean over the standard deviation. So he is 1.5. His salary is 1.5 standard deviations above average in his department. Okay, let's do the female. She makes, or the mean is 13.5 with that standard deviation. She actually makes 15.75, so she is making more than him. However, relative to her peers, let's see where she's located in her department. X minus the mean over the standard deviation. X minus the mean over the standard deviation. She's 1.25 standard deviations above the average peer in her department. So, relative to their respective departments, even though the wife gets more money per hour, who actually is higher up in his or her respective department? Well, the husband earns more respective to his department because he is more standard deviations above the mean. That's, 1.5 versus 1.25. All right. So I think that concludes what we're talking about here. And now you're going to do this assignment to take into account all those different things that you have learned on this normal model. All right. Hope that helped you. Good luck to you.